Hello everyone, my name is Muhammad Riaz. Firstly, I would like to introduce all my teammates. I myself Muhammad Riaz, and then comes Riyan, Hanish, Purna as well as Akash. Our team is mentored by Dr. Deepika ma'am. Our project is about building an agriculture chatbot using RAG as well as the agent systems. Our project is inspired by recent RAG as well as the agent frameworks that gives us domain specific as well as the context rich answers using semantic retrieval as well as the dynamic data integration. So the base paper consists of a RAG system where the user's query is semantically retrieved from the database and those passages are passed on to the existing LLMs which they have connected for improving the answers or the quality of LLM based answers. The main goal of our project is to remove the hallucination of the people or the anyone using this chatbot like agriculture students or the agronomists etc, so that accuracy and the precision can be improved by not only retrieving the data from the static data but integrating the dynamic data so that the response generated would be very contextually and domain specifically enriched answer. Problem is the general chatbots are inefficient as well as insufficient for the farmers, agronomists and agriculture students because it lacks precision, which is very vital because precision, accuracy and context aware advices are very important nowadays because it directly improves the decision making process as well as it boosts the farm's productivity. I strongly believe that precision is paramount for modern farming. For this, we have proposed a solution. So the previous paper has only the standard RAG system which fails when there is a dynamic data requirement. So we have proposed a solution where the agent as well as the RAG system are integrated together. If there is a need of knowledge database, the agent directly calls the static database, and if there is a requirement of any dynamic data, then it gives a call to the dynamic API. Now you may be getting a doubt why to use dynamic data. So the dynamic data is to ensure that the answer or the response generated by the LLM should be contextually accurate and also up to date using relevant information. So we try to deliver an outcome which is robust as well as context rich answer in the agriculture sector. Our chatbot supports rapid retrieval of factual data and it integrates external APIs for any dynamic data requirement. Here comes the project scope. Firstly, we will be discussing about the in-scope implementation. We can actually create vector database using the agriculture data which have been collected using sentence transformer and store them in the files database. We can also develop an agent layer which will be routing the queries between the database as well as the dynamic API. We can also build a RAG system using all the resources available, and also we can build a core backend architecture and we can integrate APIs with that using an agent. Now coming on to the out of scope, all these things can actually be done, but for now we are not able to implement this. Like we can integrate some paid APIs, also the proprietary market data which is available, but for now we are not doing that. And we can directly integrate the project with on-site IoT sensor data, and we can also develop this model and full and make it ready for a full-scale production and deploy it. Well, coming on to the architecture, we have collected data of different formats like CSVs, PDF, etc., and we have converted them into vector embeddings using sentence transformer, and we have stored them in vector database called Facebook Artificial Intelligence Similarity Search Database. The main reason for using this database is because we can retrieve similar chunks of data according to the user's query. So this is all about knowledge base. Now coming to the working. User gives a query. This query is then passed on to the RAG system, which checks if the user's query is anyhow similar to the data present in the database. If yes, then it retrieves the data from the database and passes on to the LLM. If the query is out of the knowledge base, then an AI agent is called, which is connected to external APIs. It retrieves the data from external APIs and it passes on to the LLM. The knowledge present in the database is passed from RAG to the LLM. Both of this data is taken by the LLM, and this LLM generates a context-rich as well as domain-specific output in the form of text. Well, we have completed collecting the data sets related to agriculture and converted them into the vector embeddings and stored them in the database. Now we'll be focusing on building a robust agentic as well as RAG pipeline, which will be tested using different LLMs. The best LLM which delivers the context rich as well as the domain specific answer will be used for the next milestone. By the next milestone, we plan to deliver the complete working model and start building the web application for that. So that's it for today. Thank you so much. Hope you people enjoyed the video. Thank you.